This video is all about high voltage system. The use of high voltage electrical system in ships is about to be discussed. In order to reduce the current, a high voltage is required. For instance, consider a system that is 400 volts and the current is 3300 ampere. It is equivalent to a system of the same power at 6 kV, then the current produced at 220 ampere. In maritime industry, voltage about 1 kV is called high voltage, and voltage below 1 kV or 1000 volt is called low voltage. 3.3 kV, 6.6 kV, and 11 kV are the typical high voltage in marine. Here are some high voltage equipment which requires high voltage installations. Generators, high voltage switchboard with protection devices, switch gears, and instrumentation. High voltage motors or compressors, air conditioners, propulsion, and thrusters. High voltage cables, step-down transformer, high voltage to low voltage for low voltage consumers. High voltage 6.6 kV and 2.9 kV step-down transformer for motors and propulsion converter. The main hazard or danger of electrical work on high voltage system is high voltage electrical shock. So, personnel in work must keep in mind safety first. Risk assessment must be carried out in high voltage switchboard and equipment before any personnel is allowed to work. A permit to work or work authorization must also be in place before starting work in high voltage system. Earthing down procedures and isolation procedures must be drawn with utmost care. So, the working function of a transformer. Transformer is a passive electrical device that transfers electrical voltage levels from a circuit to another through the process of electromagnetic induction. It is also mostly used to increase the voltage levels between circuits, which is called step-up, or decrease the voltage called step-down transformer. Today, I'm going to explain the working function of a transformer. So this is the main part of the transformer. It is called the core or the heart of the transformer. It is made up of iron or silicon, steel, or ferromagnetic materials. It is thin metal strips and laminations insulated by a coat of varnishes or papers. The core of three-phase transformer consists of three limbs in the same plane, and each limb carries both low voltage winding and high voltage winding. The core provides a magnetic flux around the core. The first winding is also known as a coil. When it is supplied by an alternating electrical source, the alternating current through the winding produces a continually changing and alternating flux surrounding it. If another winding is brought close to the first winding, some portion of this alternating flux will link with the second winding. As this flux is continually changing the amplitude and direction, there must be a changing flux linkage in the secondary winding or coil. If the current of the secondary winding is closed, then a current will flow through it. This is the basic working principle of a transformer. The winding which receives electrical signal power from the source is known as the primary winding. The winding which gives the desired output voltage due to mutual induction is commonly known as the secondary winding. Here, if the number of secondary coil turns is greater than the number of turns primary coils and 1, this is called a step-up transformer. That means increasing voltage between the primary to secondary winding. Conversely, a transformer that decreases voltage between primary to secondary windings as a step-down transformer. The alternating current through the primary winding of each phase produces a continually changing magnetic field that surrounds the winding. Here, This magnetic field is linked with the secondary winding by magnetic flux which flows through the transformer core. EMF will be produced at the secondary windings based on Faraday's law, and this induced EMF is defined as mutually developed DMF. Insulation is needed between primary and secondary windings to prevent short circuit. To receive electric energy from the transformer, insulated bushings are needed. During its working or transferring the power from the primary to the secondary winding, various energy losses happen, like eddies current loss, hysteresis losses, copper losses. All these losses generated heat. To prevent heat, transformer oil is used inside a tank. The main role of transformer oil is to act as a coolant and to insulate. Transformer oil is an exceptional heat conductor and can effectively reduce the copper's coil temperature, stopping them from burning. Not only that, externally cooling tubes or radiators are there. The radiator or the transformer accelerates the cooling rate. Thus, it plays a key role to increase the loading capacity of an electrical transformer. A Buchholz relay is used to detach any fault inside the transformer. So that's all about the functional, operational, and safety requirements of a marine high voltage system. Thank you.